Okay, so all right, so we have. I think we wait for another 2 minutes and then we start. Let me share my screen with you. Okay, so here we are. Control Shift H. Okay, so I think we can start now, and I have a couple of uh, things to say before I start. Or So by default, what I have done is just to you know reduce the confusion. I've unchecked the option to unmute yourself. Like any of the participant will not be able to unmute yourself. That is like in the last of the webinar, we will be having our conversation maybe 10, 15, 20 minutes. At that point of time, I'll enable it, and after some time I'll also disable the chat so that we go with the things in distraction free manner. And during the session, if you have any kind of queries and so on, you just note it down on your notebook or notepad as a sideline, so that once we are into the query session, we should be able to uh, interact and discuss about all those things, right? So let's start with the session. So here is the slide deck. This is just for my purpose, so that I should not you know deviate from the plan what I have done for today. So starting from my introduction, I think a couple of people are new who are attending my webinar. So my name is Anupinder Singh. I have been teaching computer science students since last 9 10 years, and most of the subjects which I have covered are the core computer science subjects. And overall, from last 1.5 year, I've been into machine learning. It started with the problem statement of my PhD, and then no, moving on, I've went into some of the detailed steps on the implementation part. So I thought of why not let's go and talk about it and discuss it with the community, the people who are still beginners, because at the starting there have been a lot of confusion that which path to follow, what algorithm shall I go for, how the things are implemented, what are the no general nomenclatures are there for implementing the machine learning based algorithms, and so on. So there are plenty of things which are there in a beginner's mind, and uh, there are a lot of confusion around this process. So this webinar, getting started with machine learning, is all based on that, so that you should be able to have a bird's eye view regarding this particular topic, and you should be able to decide on that. Okay, what path shall I be following, what procedures shall I be looking into, what are the different kind of processes are there which I should be taking care of. Is there any kind of questions which I need to look at, and so on. So these are some of the things uh, overall, like introduction part. So looking into this particular prospect. So let's start with setting up the agenda. And uh, because primarily my audience are across the world, so I'll be having the you know, conversation in English itself. There have been a request in chat for regional language, so I will not be able to take that. I've just disabled the chat just for a while so that we should be able to concentrate on the topics. So these are some of the agendas that we have. So what is the machine learning that I'll be putting up in front of you? A lot of different definitions are there, but we will be looking into the definition with a very much practical perspective. Then why is the necessity of machine learning has occurring, and why this whole phenomena has grown to such an extent in last couple of years. What was the reason behind it? That we look at. What are the different kind of what are the implementation processes like? We'll be discussing about the steps and the procedures that are involved into it. Alongside with all with the topic, wherever it is applicable, I'll be giving you some of the application examples related to the machine learning, and then comes as the what learning path should be followed. So this is what is the agenda I thought about, and hopefully it will get you an idea about the this concept, right? So starting with what is machine learning. So if I go with the basic context in terms of some definition, so it says the machine learning is the field of study that gives computer the ability to learn without being programmed. So two very much important attributes we are talking about: learn, ability to learn, and without being explicitly programmed. That is very important, right? So a lot of time, being in CSE, one of the primary activity of a computer science engineer, or a computer science student, or faculty, is to have a programmed examples, right? So one of the most important thing which machine learning based approach looks for is the ability to learn itself, and without explicitly programming those rules, basically, right? And how this learning happens, primarily this learning happens on the basis of the data, from the data, and it makes decision or predicate or predictions on the basis of that, right? So data is something which is very important. So until unless we are having enough data, we will not be able to make the ability to learn for a computer program in a particular context, right? Another thing is it also learns to identify the patterns without being explicitly programmed to. So this is these are the two basic prospects of one coin. So one is data is something which is very important, and that data could be from any domain. It could be from some kind of inventory, it could be some kind of sales data, it could be some kind of weather data, it could be some kind of student data, right? Their exam results and so on. And that data actually is being processed to find the patterns, right? And once the patterns are identified, based on those patterns, the decisions or predictions can be made out of it. So that's the fundamental concept behind the machine learning, that you are supposed to do such give the ability to the program to the computer to program in such a way by themselves, so that they should be able to learn based on the data which has been provided to them, right? And what they do with the data, they do the pattern identification, and once the pattern identification is being done, in that by using that context of the pattern, they do the decisions, or do these predictions correspondingly, right? So one of the most prominent example which you find in your day-to-day life is basically the spam filters, right? This is the best example that is being implemented and matured enough in last decade, that you rarely need to push the emails to the spam folder by explicitly clicking on a spam button, right? Or spam label, or labeling it as a spam, right? So if you look at the pattern, generally what happens is the engines which are working on identifying the spam, they work on identifying various parameters. They work on identifying the context, they work on identifying certain words, they work on identifying certain kind of email addresses, on which they from which the email is being sent, the servers from it is being sent, the type of signatures it contain correspondingly. These are only few of the parameters, right? So with the prospect of that, there is one more definition, which was being given by Tom Mikhail in 1997, and what it states is that any of a computer program is said to be learned from experience, right? So we have given that experience as as a identifying notation. So we are talking about experience here right now. How we get the experience? Again, it will come from the data. So learn from the experience with respect to some task, right? Learn from the experience with respect to some task T and some performance measure P. Okay. So if I take this particular definition in context of my spam related identification, so what will be the experience for that this particular kind of computer program? So let's say a spam filter we are talking about. This is the program which is going to identify that is the email is spam or not. So experience comes from the data. So what is the data here? Data is a email, right? So whatever the email contains, the email has different attributes: sender name, sender server, its subject line, its content, its signature, right? And so on. So with respect to some tasks, what is the task? So task here is basically either the email will be spam or it will be a normal or ham email, right? So we anything which is suspicious, it will be spam, otherwise it will be normal, or can also be said as ham. And some performance measures. So based on whatever the email has been received, is that email is really a spam or not? So true spam, right? In case if it is really a spam, so let's say E1 is being received, so it's a true spam, so it is sent to the spam folder. Whereas if E2 is received, but it is sent to the spam folder, but it is not a spam email, so it is a false spam. So the performance based on what you have labeled a particular email is actually going to define that, okay, how I'm going to learn from the performance of this particular identification or classification of the email. So E1 was actually a spam and it was marked spam, but E2 was not actually the spam, but it is marked spam and it's a false spam, right? So in this particular case, the performance for this particular program will be 1 by 2, right? So 50% of the probability is that it is going to mark the similar kind of E2 emails as a spam, even though they are not spams, right? So based on this particular part, if I extend this particular definition, the second part, if its performance on task T, that means identification of spam or normal, as measured by P, so we have identified how we measure it, dependent number of true spam versus false spam. It improves the experience. So let's say your computer program identified and given a penalty on this particular E2 email, that even though this email was legitimate but marked as spam, so next time whenever you get this email, you should not be marking it as a spam, right? So this has been explicitly done by the user sometime, as well as the system too, right? So we label it in some way. So with that particular prospect, if from the experience, if from the experience the performance is increased for that particular task and that particular place, so that brings you the machine learning environment, right? So overall this is what exactly happens. So you, in every machine learning based problem, if it is supposed to be solved with the machine learning, you need to identify what exactly is the task, right? What exactly is the experience you are looking corresponding to that particular task, okay? And how you're going to measure the performance. So these three parameters are actually going to give you the base for identification that does your problem requires to be solved by using the machine learning based procedures or AI based procedures, or by the traditional methods, right? So this is what Tom has actually given us in terms of simplifying the particular approach. So this is very important definition. You will find it in a lot of books. You will find it in a lot of blogs, and so on. So this is the core essence that is there for your machine learning program. Now, even though we are talking about machine learning, but we also need to understand the big picture around this machine learning concept. So machine learning itself is not a broad concept. It is actually a subset of your artificial intelligence, right? So artificial intelligence, if you talk about artificial intelligence, it gives you a very broad spectrum of use cases, right? So NLP is basically artificial intelligence, robotics is artificial intelligence, right? Self-driving cars, embedded systems are which are self decision making things, they all are artificial intelligence. So artificial intelligence is a very broad spectrum domain where a lot of different kind of application goes around. There have been a lot of different kind of approaches which are being implemented into this. But machine learning, when you come to machine learning, it brings you a smaller subset in comparison to what you get in the artificial intelligence part. So AI is a broad term, whereas machine learning is a core subset of that. Now, if you go more further into the subset of this, machine learning becomes the deep learning. If you are doing it in terms of neural networks, in terms of multiple layers of learning, ensemble learnings, and all that stuff. So you get into the deep learning part, and it is the primary, combination of algorithms which are being utilized for various real life applications. Now then, from these subset, you get a big data domain, because a lot of data has been generated for the application. So if we look at our own usage of the different kind of applications, so if I give you my example, I use Gmail, I use Google Drive, I click a lot of photographs, I do a lot of webinars, so recording is being done. I send a lot of emails regarding the promotion of my webinars, and the follow up emails for sharing the resources, and so on. So if I look at the broader prospect, I click around 40 to 50 photographs per day, just for the purpose of my work. I create presentations, I put the images into that, so there is a redundancy of the data. Then I push them to Google Drive, again another redundancy, but that set of data has been generated. So let's say my core photographs are of around 100 MB, then it goes to my presentation, becomes another 50 let's say another odd 100 MB, so 200 MB data has been generated. And mind it, my phone is also synced with cloud. So that presentation goes to Drive. That Drive, Google Drive, is another is having another 100 MB across it. My Gmail contains a lot of information, including my presentation, my photographs, and so on. So if I talk about a general scenario, in a single day I generate around 200 to 300 MB of data, which goes over the internet. So if we look at the broader picture, let's say there are 100 people like me, right? So you get around 20,000 MB of data. So somewhere around 20 GB of data we are talking about, right? So that's an approximate on 100 people. If we take it to million, so you can look at the scale what the data is being generated. And I'm not talking about the Facebook usage or LinkedIn usage which I am doing. The data which I am generating over there in the background, whatever they are tracking about me, just to push the sponsored ad as a user to me. So the data which has been generated for creating my personality over there in terms of serving the ads, that is another set of data which has been generated. So look at the data on the daily basis, what has been generated. Now finding the pattern and finding the details, or extracting the valuable information out of that particular data, is where the data science comes in the picture. And a lot of statistical instruments, or a lot of statistical models are being used correspondingly. So you cannot look artificial intelligence, machine learning, deep learning, big data, and data science as a different entities. They all are integrated to each other, and depending upon what is the problem you have at hand to solve, and what use case are you looking at to solve in terms of solving some real life problem. You have to see that, okay, which picture will come in that particular use case. So you have to identify it very very carefully, that okay, is this is something which I need to solve through the machine learning, or is this is something which I can solve by using just traditional methods, right? The traditional programming paradigms and so on, right? So this is something which you should keep in mind when you are working on any of the problem statement or any of the scenario that you want to implement using your work, right? So next one is the necessity, because we have already discussed about the big little bit of big data. So why the necessity of machine learning is there? So there broadly there are four basic things. So increase in data generation, I've already spoken about that. What data I'm generating, you might also be generating the similar sort of data. And in fact, if you look at your Android based phone, in a day they send a lot of information about your personal usage, right? So your phone's usage, and the application usage. So that data is very 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 intense, and immense amount of data has been sent for millions and millions of users, right? So that's what is your increase in data generation. And there have been a report uh, from the storage firms, like if you talk about AWS and so on, they publish their data related reports, that what storages are being used and what is the scale they are happening, right? So this is what you can find on internet as well, so you can read about all those details. Now next thing is and the more important thing is for the necessity of machine learning is improved decision making, right? So a lot of companies are working on their data to find the pattern and then serving their customers on the basis of that. So let's talk about Amazon. I think there is no one in the attendees group who hasn't used the Amazon, right? So once you go on Amazon and start looking for your product, they give you a lot of different kind of suggestions, right? Now if you are very new, if you are new user to the Amazon, there may be some weird suggestions as well. But if you have consistently used Amazon for, let's say, 2 3 months, they start giving you suggestion as per what you might be interested on, right? So how exactly they get all the information is the insights they get from the data, and then they start serving you the different kind of list of products, right? So let's say if in last couple of months I uh, did shopping for some of the products which are relevant to the recording of these sessions, right? So I bought one mic, I bought one stand for that particular mic, and then can you imagine what suggestions they have started giving me? They have given me a suggestion for standing desk. They have given me a suggestion for elevated stand for my laptop, or cooling laptop. They gave me a suggestion for a table which I can use, which I might buy to use while sitting on my bed comfortably, right? They have started suggesting me stationaries corresponding to it, because once I find I search for the printer and so on. So they track a lot of different kind of data correspondingly. Similarly, if you talk about Facebook, you go and search for any product. Before going to Facebook, they will send you out the corresponding information based on it, even though the cookies are being dropped on your machine. But over the period of time, even that cookie is there. Apart from that particular single product, you will also given the suggestions for the similar type of product correspondingly. So it's not like that you are no work you're surfing the web in dark. You are putting your digital footprints in terms of data which these companies collect and process, and based on that they improve their decisions for serving their client base in a much better way, in terms of increasing the user experiences as well as their sales, right? So how this improve decision making happening is because of uncovering of the patterns and trends in the data, right? So this is the prominent thing they are looking for, and solving the complex problems. I hope you have heard about AlphaGo based reinforcement learning program, right? So it was one of the achievements in machine learning domain, in fact deep learning domain, where the particular program was set to play against the world champion of AlphaGo, right? There were three sets, two were lost by the champion, and one was no won by that. So you can find the link on the YouTube. It's one of the intense videos I have no watched till date. It literally showed you that how a human will react to such kind of uh, capability of machine. But you can also appreciate the way how the computer systems are learning from their own experiences, even though during that particular game the learning algorithm was not on, no, it was not enabled. Whatever the AlphaGo program has learned is from its past experiences, what that program has followed through the training process, right? It was not, the learning process was not enabled during that particular uh, set of three matches, right? But still it was it's a very complex game, right? AlphaGo is a very complex game. Chess is another complex problem. Even though you can, have all the number of permutation combinations corresponding to all these steps, but they are complex problems which, if you try to solve using the traditional set of approaches, they become very complex in terms of implementation of code. You have to write a lot of large pieces of code. In comparison to that, if you try to implement them by using the machine learning based algorithms, the code will be very small. The manageable the manageability of that particular code will be very easy for you, and the training and testing of that particular software program, the machine learning program, will also be suitable and manageable, right? So these are the broad four categories why the necessity of the machine learning is there. Now, how we decide that when to use the machine learning program? So broadly, there are four basic things which we look at when we are trying to, solve any problem by using the machine learning approach, right? So it's very crucial step where you decide that do you want to really go for the machine learning based approach, or you can do it by the traditional itself. So the very first thing that you should be looking at is the problem, which requires a lot of fine tuning and long list of rules to be implemented over a period of time, right? So let's again talk about the spam filter based program. So let's say if you are writing this program from the scratch using a traditional approach, what exactly you will be doing is you might be looking into a prospect of like creating a set of rules using if else condition, or a similar kind of decision structure, uh, and you will, put the corresponding words, right? So there may be a word, let's say sale, there may be a word, let's say uh, free, like there are certain spam mails where it says that I have my property, and somebody has died and there has been so and so amount with this. So you find those specific words and then put them into the rule. Then again, in the iterative way, then you look at that somebody is sending the phishing emails where the text data, where the text of the anchor link is saying, let's say, www.google.com, and whereas the address which that link is forwarding to some xyz .com. So if you try to write that rule, that so all those rules you have to identify over the period of time, and you have to implement. And let's say after every day you are writing two rules, and after 100 days you have written 200 rules, and if you wanted to change those rules, you have to go across the different set of lines and so on. So these set of no procedures, or these type of use cases, if they are there, then for this the machine learning approach is best way to do, because you need not to write the particular set of rules. You just pass on the parameters or attributes which are there in your email, and then on the basis of that there are a number of different kind of approaches. So NLP is one of the approach. SVM is another approach which can be used for this. uh, Nearest neighbor is another approach which can use for corresponding problem solving. So these kind of approaches have shorter code. You need not to explicitly write down the rules and so on. So this is the very first indication about a particular problem. If there is a requirement for fine tuning for longer period of time for writing the rules, that means you should be looking into the ML approach. Next is complex problems for which using a traditional operation approach yields no good results. So one of the way for this is the if you read about the research, if you read the research papers in cloud computing, there have been a lot of people who are working on the virtualization, on the virtual machine migration concepts and scheduling concepts, which have been using the heuristic approaches, right? So generally a typical approach of mapping a task to a virtual machine and a virtual machine to a host is NP complete problem, right? So there is no specific optimized results if you have n number of tasks to be mapped to n number of virtual machines and n number of virtual machines to n number of tasks. So in that particular case, you need to find out uh, a, a great approach where the time span spent on the optimization should be lesser and should be based on the previous data as well if you have certain kind of learning. So in that particular approach, the ML is a great one to implement. Another is parameters fluctuating environments, like variety of new data is generated within a short span of period. So, where is my marker? Okay. So this is what I'm talking about right now. So fluctuating environments, like if I say a new data is generated in a very short span of time, so stock market is one of the great example, right? Apart from this, your weather report. My God, your weather reports. Okay, so these are the two set of particular applications which are there, which generates a lot of data over a period of time in a very limited period. So let's say if I talk about stock market, if it starts at 9 o'clock, and by 10 o'clock a lot of fluctuation will happen during that particular time period. So within 1 hour there may be a lot of ups and downs in the trend line. So how you're going to predict on that particular set of data? What are the different parameters are there that work correspondingly? So if you do the manual calculation or traditional approach, if you use a traditional approach to do it, you have to again write a lot of different kind of rules. You have to take care of a lot of different kind of constraints. You have to take care of a lot of different kind of data to be pulled from in stream. So all that stuff requires a lot of complexity, and by the time you calculate, your calculation happens, that trend line may be in a opposite direction in that case. So based on the certain kind of parameters, we generate models in the machine learning, and then based on those models, the immediate results can be produced with certain level of probability, right? So higher the probability we get, that means the more suitable the output or the predicted trend line will be. So these kind of situations similar happens with the weather reports. Let's say you are flying an aeroplane, right? You need to have a real time data in that particular case, or you might be cruising your ship, and you require a real time weather report, and the prediction that the path which you are following is that path is going to have a severe weather conditions or not, right? So that particular predictability is required to be done, because once you take the course, there is no turning back for a certain period of time, and by the time you try to take the diverging path, you might get stuck in that particular bad weather. So a lot of different kind of application and similar applications are there, and you have to decide on this particular parameter that, okay, if the new data is generated in a very short period of time, then ML is a right approach for that. Then another part is getting insight about the complex problem and the large amount of data. That's another thing. A lot of data warehouses are being generated these days, right? They are hosting the petabytes of data, right? Facebook has a petabyte of data, and on daily basis they generate a lot of data, which is supposed to be processed and found some insights from that, so that the business can get benefited from it. Similarly, Google also stores a lot of data, and they process it for the further analysis. If you have gone through Google Trends portal, you might have seen certain insights from these kind of data as well. So these are the four common approaches, or four common indications that you should be deciding on, that shall you be going for the ML based approach or not, or you should be looking into the traditional methods, or some alternative ways, right? So based on all these things, you generally decide on that, okay, what sort of machine learning approach I need to follow in terms of categorization based on the data, right? So broadly, there are if you talk about types of the machine learning, these are the three broad types of the machine learning, or the approaches which are being used. One is the supervised learning, one of the most common approach. And if you know that this particular type of approach requires a labeled data, right? So if you have any data which has labels included to it, which has certain set of large data which is being labeled in terms of, so that we should be able to identify the outcomes of that particular uh, uh, row or tuple in that particular prospect. So let's say if I'm buying some of the products on the particular online store in that particular place, my records of purchases will include the product. It will include what sort of payment method I use. It includes does the payment was successful or not, based on what payment method I have been using, right? So supervised learning approach have also have label corresponding to it in terms of, let's say, success or unsuccess, right? So that becomes a label for me. So generally it goes into the classification approach, not the prediction approach. But yes, supervised learning can be used for both prospects, classification and the prediction part as well. So supervised learning contains a label data. That's a very crucial identification for this. Whereas when you move toward the unsupervised learning, there is data available, but there is no corresponding label available to it. Now, taking another example to this particular part is that spam filter again, right? So any email, let's say if I'm working in a supervised learning mode as a user Anupinder Singh, whatever the email comes to me, if I feel that email is spam, right, I just go and explicitly hit that spam button on the particular interface, right? So once I do that, the label has been generated, whereas by default the label will be no spam. Okay, so that is a label data. Whereas the unsupervised learning in the context is, let's say, on a broader prospect, let's say there are 100 users who are using that particular email, but Anupinder has marked certain email as a spam, and other odd 20-25 users have received that particular email. Now in this particular unsupervised learning, for other user, the same algorithm works on the basis of what data does it contain, right? Based on that type of data, right, and the label of data, now the similarity index will be no comes in the picture for the other users who didn't took action on that particular email as spam, but it's a potential spam, right? So your program will look at the similarity, that okay, what email was received by the user other than Anupinder, does that email has a similar properties as the Anupinder marked certain email as a spam? If the similarity index is on a higher part, that particular email can be marked spam as well, right? So this learning happens on the basis of what data you have and what similarity indexes you get corresponding to it. Okay, so there have been number of algorithms which are there, which can be used for the unsupervised learning, and one of the best algorithm is the k nearest neighbor, right? So I try to identify the similarity index corresponding to it. Apart from this, there are there are certain decision trees, random forest algorithm. There is neural network that you can use for this, and so on. So in comparison to in comparison to the supervised learning, unsupervised learning has a data, but there is no or limited label corresponding to it, and you work on the basis of the similarity index. Now then comes is the reinforcement learning. So reinforcement learning doesn't contain any data, right? You just simply there may be some data, but there are no basic classification for that particular data. So you work on the basis of, when you talk about the reinforcement learning, you talk on the basis of rewards and penalty, right? Or punishment. Okay, so when you talk about reward and penalty or punishment, you say that, let's say there are two different kind of emails which are being received by a particular server, right? And the machine learning algorithm is going to work around it. So based on some sort of assumptions, E1 and E2, there are two emails. E1 is being marked as spam, and it is being sent into the spam folder, right? So here the E1 is, whereas in the inbox the E2 is going to be received. Now when the user looks at the spam folder and it finds E2 is a legitimate email, and it's not something which should be marked as spam, the user comes to this particular email and marks it not spam. So in this particular case, what happens is, for E2 a reward is given, whereas for E1 a penalty will be given on that particular learning algorithm, so that next time whenever an email similar to, let's say, E3 is the email which is similar to E1 has been received by this particular learning server, right? At that point of time, this learning server will look at that, okay, does the similar kind of email which was marked previously spam was rewarded or punished? So if it is punished for putting that particular E1 as spam, so that means the E2 E3 which is received just now and has a higher similarity index, let's say in the predictability not in the probability index, 95% is the similarity of these two emails. So in that particular case, the E3 will not be marked spam, but it will be delivered to the inbox itself, right? So based on this reward and penalty game, the spam filter is going to learn from the receiving emails and what responses are being given to those emails which are being marked uh, you know spam or not. The similar way can also happen in terms of not marking an email as a spam. So that particular prospect comes in. So ML algo is here. The emails are being received, right? So let's say E1, E2, E3, and E4. So here is my inbox and here is my spam. So let's say the E2 this time is being sent over here, whereas all the other emails are being sent over here. So E1, E3, and E4 are being here. Now the user comes to uh, this particular place, and it says that, okay, E4 is not a legitimate email and it should be marked spam. So if a user marks it spam, again a penalty will be provided to this particular algorithm, and the E4 will be sent to the spam by the user. So whatever the next email, let's say E5, comes into the system for the analysis, and the similarity index of this particular email is, let's say, 95% in the probability mode. So this E5 will be now marked as a spam. So it works in both the ways, right? So reinforcement learning is basically imitating the way how humans are learning, right? So if I talk about my child, and if he does something wrong, and if I go and try to teach him in some way by giving him reward on some kind of penalty in terms of some restrictions on his play and so on. So the algorithms are also working in the similar way. So you are restricting the algorithm for doing one action and giving some kind of reward on the other action. So this is how the three different broad types of machine learning algorithms are there. Most of the machine learning algorithm which beginners are starting working with is the supervised learning, right? So this is the first place which you start with, then you move on to the unsupervised, and then you move on to the supervised learning. So this is the trend that you get in terms of your implementation, your learning phase, right? So there are number of different kind of algorithms, so starting from the easy to medium to the difficult level. So it's up to you where you wanted to get started with. So just to give you an idea that what sort of different kind of categories are happening into this particular type of algorithm. So let's talk about the supervised learning first. So broadly, there are classification and regression problems which are being worked on. Regression is basically the prediction part, right? So uh, some examples are like here: population growth prediction for a particular city, country, or district, and so on. Estimating the life expectancy based on what sort of current diseases they have, what sort of vital parameters a particular person is having uh, in terms of their health. Then market forecasting, so generally stock marketing, weather forecasting, then advertising popularity prediction, and so on. So classification is diagnostics. Generally, this is one of the most popular domains in research these days. Customer retention related information. Image classification, I think a lot of you have used Google Photos. They do pretty good image classification, and there have been couple of algorithms, and one of the best algorithm is CNN algorithm. And then you have identity fraud detection. This is something which has been matured enough in past few years, 4 5 years. I've been using a couple of credit cards from different banks, and they have a pretty good system to detect what sort of payment pattern you are doing as their customer. And if you do something which is not in that particular range, they give you immediate notifications correspondingly. Now when you talk about the unsupervised learning mode, the dimensionality reduction and clustering are the two core areas where they have been working. So customer segmentation is one of the major attraction in this particular part. Then targeting markets, and then recommender systems, especially the friend requests which you get, the suggestions which you get comes from this particular part, depending upon what network you are carrying on your friend list. Then dimensionality reduction is basically done as a pre-processing stage for pattern identification problems, right? So big data visualization is being done as a primary application to this. Meaningful compression, structure discovery. If you know how the Twitter based trends are being analyzed, that is done from this. Feature elicitations are being done. Corresponding to the reinforcement learning, you have game AI. So we spoke about the AlphaGo. We spoke about chess as well, right? Apart from this, skill acquisition is another one, right? So skill acquisition is basically a field from the robotics. Then you have robot navigation correspondingly. So Boston Robotics, I think you might have seen certain videos corresponding to them. Real time decisions, they are something which are being relevantly used in various disaster management applications, right? So these are some of the broader application areas. And if you go deep down into the very specific algorithms, you might find a lot of other application prospects as well, right? So this is what we have in terms of types of different kind of learnings which we have in our system. Now apart from this, there are two more categories of the algorithms which you might find, and you might find them interested in terms of solving your problem at hand. So one is the batch learning algorithm. This is basically an approach that how we approach the machine learning by using those algorithms, right? So batch learning algorithms and online learning algorithms. So when you talk about the batch learning algorithms, what generally happens is you take the data and you split the data into test and train. So this is a general basic practice. The best practices, you say they that the data set which is used for training the model is basically divided into two. One is the train model and one is the test model. Now why we do it, I just discuss this in a couple of minutes. But this train data is then being sent to the model, and then that model has been validated correspondingly for its you know uh, accuracy. So once the accuracy is being maintained, it is being pushed for further validation with the test data. And if that test data is also validating the model predictions or model classification, if the accuracy is to the acceptable point, then this whole model is being deployed on the system, right? The deployment is only happening after the scoring that you get for training that particular model. Now when we talk about the model, this is basically by using some kind of algorithm. It may be SVM, it may be a random forest, it may be decision tree, it may be KNN algorithm, and so on. So this model is basically going to have the training or have the pattern identification from this particular training data, and then the model is being saved with certain set of relevant corrected weights and parameters, and then that is being tested and scoring is being generated, and once the scoring is acceptable, that is being deployed. Whereas if you talk about the online learning algorithm, we are, instead of relying on the data completely, in batch learning, this is like creating a jar or creating a setup file. We are done, right? Whereas in online learning, we assume some model based on certain assumptions with respect to the parameter and with respect to the data, and corresponding to that particular assumption, we feed the real time data to this particular system, and then on the basis of prediction, we evolve this particular model by fine tuning its parameters, its inside its internal measuring parameters, right? So once that particular measuring parameters are being evolved properly after a number of iterations, you can see only two iterations, there could be 100 iterations, there could be 1,000 iterations, and so on. This model is being put into the production, and again, in the production, when I say production, that means we deploy it, and in the production, the learning doesn't stop. The learning is being continuous throughout the process. Your model do the prediction, it sees what uh, is the prediction is okay or not, and based on that, the model is being evolved. So online learning algorithms are basically based on, most of the time you will find they are reinforcement learning based approaches. They use that particular approach. Now this type of approach is basically no if I give you the example, the spam filter is this kind of approach. You feed the data to the model evolves on the basis of that, and then the production happens, and then you correct it on the basis of what user inputs and so on. So this is a iterative cycle, endless cycle, it goes on. Whereas if you do the batch learning algorithm, you have to first collect the data, you have to train the model, you have to deploy it. If you find some anomalies, you have to again bring this thing to the white this design board again. You have to again train the data, you have to again collect the data, updated data, and then you have to split it into train and test, train the model again, validate it, and then again do the testing and then deploy. So this is an iterative cycle. This type of cycle generally no have a time frame of 1 week to 1 month, depending upon how frequently the data has been generated. This approach can be used in these kind of data generation. Whereas here, if your data is being fed every hour, if the data is updated or changed every hour, and you need to forecast on the basis of that, in that particular prospect, the online learning approach is required to be used for that particular algorithm implementation. Then another type of thing which comes in the picture is the instance based or model based. So the approach is almost same, but the way of identifying the things are different. So in instance based, you are working on the on the data which is basically unlabeled. Most of the time you will be working on the data which is unlabeled data, whereas this particular approach is using on the labeled data, and most of the time you will find a supervised learning approach. Here you will most of the time find a unsupervised learning approach, right? So in this particular type in this particular category which is instance based, and this here the model based, what is the basic difference? Any instance which comes in the real time when you are doing some kind of prediction, if the classification of this data is based on the surrounding data points, then it becomes an instance based. When I say surrounding, so if we look at this particular example, what is happening is the circles are indicating what is the limit of that surrounding. So if I talk about the internal surrounding, the k is equals to 3. So this example is basically from k nearest neighbor algorithm. So if I want to identify this particular instance, that okay, what type of instance is it? Is it a star or is it a triangle, right? Based on the nearest three particular set of data points, I'll be identifying this particular question mark as triangle. Why? Because in this particular circle there is only one star and two triangles. So because the majority of the data points are triangles, so we consider this particular instance as a particular instance of triangle. Whereas if we take an outer circle where my k is equals to 7, that means the 7 nearest neighbors I'm going to use for deciding this particular parameter. In this particular case, what is going to happen is there are one, two, three, and four stars, whereas one, two, and three triangles. Okay, so here the majority of the neighbors are stars. So in this particular case, the question mark will be given as a star or will be marked as a star. So when you talk about the nearest neighbor, the broader the search uh, region, the broader the search region you have in the KNN model, more generalization you are going to get in terms of your instance classification. Whereas if we talk about the model based approach, now model based approach, what is happening is you have already done the batch learning corresponding to it. So model based approach is also a batch learning approach. You have made that particular model learn in a way that okay, by this line is going to indicate that what is the limit for the triangles and what is the limit for the squares. So if my particular instance comes into one of the territories, it will be identified as either triangle or square. So for this particular instance, the cross will be marked as triangle based on the learning what has happened during the batch learning process for this particular model. So model based approach says, or if I give you a brief idea, that model based approach is that you do a learning prior to feeding the data to the system, whereas in the instance based approach is that you are using the current data corresponding to the classification part, and the learning in this particular type of instance based model learnings are by heart, right? So you try to do and look at the similarity indexes based on the neighboring nodes, right? Whereas here you have already defined the range that okay, if my particular value is between let's say 0 to 5, then it is triangle, and if it is above 5, from 5 to let's say 10, then in that particular case it is going to be a particular square instance, right? So this is what you get in terms of instance based model. So now let's summarize this. As a beginner or even as a pro, whenever I'm trying to work on a problem which is supposed to be using the ML based approach, for finding its solution and for deploying it to the production system, we need to look at all these categories based on the problem statement which is at hand, right? So first you identify on the basis of data that does this particular problem can be solved in supervised learning mode, unsupervised learning mode, or does it require a reinforcement learning, right? Now, if it is supervised mode, then batch learning approach is the best one, because the data has already been there, and if the frequency of the data generation is not very frequent, in that particular case the batch learning approach can be used. Otherwise, if the data is being generated very frequently, then the online learning algorithm is to be used. Now, adding to this, do we looking at are we looking at the similarity indexes, or are we looking at the broader indexes, right? Or do we wanted to have a real time data instance correspondingly, uh, uh, or do we need to search, do we need to classify the on the basis of the in-stream data which is happening right now? So let's say, if you take talk about the Twitter trends, how they classify the things, right? How they classify the tweets, even which are not being hashtagged, they are being done on the basis of this instance based. Whereas, if you talk about some kind of new product suggestion for your purchase in the Amazon, that is basically on the basis of model base, right? So what you have purchased in past, what is the similarity index in terms of the upcoming purchases predictions, that is based on the model, right? So this is how the things are happening. So you're looking at the combination or blend of these methods, so that you should be able to get the generalized solution towards your problem, right? So it should not be very specifically overfitted towards what you are training the model for. Okay, so we are going to talk about that as well, right? So there comes to the basic steps now. So we know what is the approach, we know what are the different kind of categories which are there, right? And we also know that what type of different kind of approaches that can be used in terms of combinations and all. So till this place, if you have any kind of suggestion, not exactly suggestion, any kind of doubts which you want to ask, I've just enabled the chat. You can put it in the chat, so that we should be able to take your confusions till this particular place, because after this is more of a implementation part, that how you can start working on it. I'll be touching upon the Kaggle platform as a startup thing, right? So anyone who have any kind of confusion queries to take, ask. Does it make sense whatever we have discussed till now? If it makes sense, just type in boom in the chat. Let's see how many of you are awake. I know in India it's 9:30, and we are, I think, connected across the zones. Let me see how many are here. So we have a lot of attendees. Yeah, everyone here. Oh, great, Sai. Yeah. Okay, so Akram and great, great. Akram, Lokesh, Sai, great. So Kupal, we'll talk about this in the later part. VM selections for the migration. This is very specific. I think you are talking about the cloud sim, right? So we'll take this question in the uh, last part of this session, right? Okay, great. So let's talk about the steps now. So if you look at the particular prospection now, we know that what are the different kind of algorithms do we have, and what are the different approaches that can be used, right? And when we are supposed when we are done with all those selection, we are supposed to do some kind of implementation. So these are certain broad steps that are being done. So the very first thing is defining your problem, right? So what is the problem, how, what sort of data it is going to have, how the user is going to approach for that particular problem statement, that particular problem solution, and so on. So you have to define all those things over here, right? So when you are defining the problem, you have to also look at gathering the data from the various sources, which is very pretty much important, because for training a child to learn about, okay, what is an apple, you will show them a red apple, tell them its properties. They will also be Your child will also be able to identify that, okay, if the apple is green, then again it is apple. Okay, if the apple is red, it is apple. If the apple is yellow, it is apple. But for particular machine learning algorithm, you have to have a plenty of data for all these categories, so that the computer program or machine learning program should be able to identify all those three instances as a single entity, that is apple, right? So here, gathering data from the various sources is very very important. If you can generate your data, great. If you cannot generate your data, go and look for different platforms. There are various platforms. One of the most popular platform is Kaggle, data dot world, data.gov, .in, uh, UCI database is there, right? Planet Lab base is there. So a lot of different kind of databases are there. Even Hadoop has, AWS has its own data sets, and so on, right? So you have to find out, as per your problem definition, what sort of data is applicable for that, right? If you cannot generate it, you have to find out the source, that from where you can fetch it, and that source should have a good enough data so that you should be able to train your model. Then prepare your data, right? Now whatever the data you get, you cannot think about it that, okay, this data will be readily available to you, right? You have to prepare your data. So cleaning the data to have a homogeneity in it, that is very 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 crucial, very very important. So you have to work on that. Okay, let's say if I have 100 columns, from those 100 columns I do not require, let's say 76 columns, so I dropped all those columns in the very first go, right? Then from 26, left out 24 no columns, I need to find out, okay, do I need to combine one or two columns together so that it can become one single data? Do I need to convert the string data into numerical data for categorization purpose, for classification purpose? Do I need to reformat these structure of the data? So maybe if you have downloaded a purchase sales data, where a company has been selling certain products to certain number of users, and the date and the amount is basically in a string format, you have to convert that particular string into the integer format, right? So that is what you are going to work that is what you are going to work on preparing the data. Even though in terms of rows, if few of the columns are null, and they are the prime columns on which, or prime attributes on which you are going to decide your model, either you have to find out the way to fill those empty rows, or for those respective columns, or you have to drop off all those rows before you actually go and send that data to the model for the training purpose, right? So that is what is the activity in the preparing of data. Then the third and the most important step is model, right? The model which you are going to choose, spot and test the applicable algorithm. Okay, so when I say test and spot and test the applicable algorithm, so is it linear regression or polynomial regression? In case if you are working on predicting any result, then linear regression or polynomial regression, which gives you better performance, which give you better prediction. Then for image for classification, is it like nearest neighbor or SVM? Okay, which gives you better accuracy in terms of identifying the instances, right? So these are some of the parameters on which you are trying to work on. One thing which I forgot to mention in the prepare your data is any data set is, as we have seen in batch mode, we said that the data set will be divided into training and test. Now, why do we do it? When you are using the complete data set for training the model, right? What you are doing is you are saying your model that, okay, this is what is this complete set of data which we have, and you should learn the pattern out of these data and then start validating on the real instances which are going to come to you, right? Now in that case, what could be happening is that data may contain some kind of bias in it. Okay, that data may contain some kind of bias in it. So what sort of bias? Let's say you have downloaded a data from the Amazon shopping, where all the products which are being sold to the customers and were relevant to the females, right? In that particular case, if you train the model from that particular product list, right, for predicting for predicting the next item to the intended user, that sort of model is not going to work on the users who are from male category, right? So in that particular case, you have to first identify the data and analyze the data, that okay, what sort of information does it contain, right? And let's say that data only contain 10% of the males and 90% of the female customer no shopping. So in that particular case, it will be biased toward the female product suggestions instead of the male product suggestions. So you have to have a balance of that. So while training the data, you may work on reducing the set of that particular data to such an extent so that the ratio could be maintained correspondingly to the male and female customers, so that the predictions can be done correspondingly. So that is the very important part in terms of defining your preparing your data. Now, when we say testing and training, so testing will should also have the similar and should also have this same you know variation in terms of what your training what your test set have. So if I say your overall set, let's say your overall set has a data of, let's say, female of 60% and male of 40%, so I'm increasing the percentage. So the test data with, let's say, these are 100 records, and you are segregating the test and uh, you know uh, what you call you're segregating this core data set into two sets. One is train. I need to just close this first, sorry. So one is for test and one is for train. So if you are saying that you are getting two data sets, so that means both of the data sets will should have the same size type of variation. So female should be 60% here, and male should be 40% here, and here again female should be 60% here and male should be 40% here. So let's say if I'm dividing it uh, in terms of 50-50, so 50% of 50 records, let's say 100 records were there, 50 records were sent for test and 50 records were sent for the training purpose. In this particular case, the 40% of because we have 40 males, so 50% of the male will be here 20, and 60% of the 60% of the females will be 30. So in here also 30 females and 20 males, so equal amount of data should be there. So this will have a minimum bias in terms of your data set. So when we have a training of the model using this particular data set, then the model will be trained as per this particular sample. And once we go and test the model on the basis of the testing data and validating the model, that whatever the prediction, let's say the this particular data is giving 90% of prediction for the successful prediction for the products which can be bought by the intended user, your data should also be close to it, maybe 88%, maybe 92%, but the variation, the standard deviation should not be more than 5 to 8% correspondingly, right? So if it is more than this, that means your model is overfitting to that particular data or underfitting to that particular data. So this is a standard approach which is being followed while working around with the spotting and testing of the applicable algorithms, as well as preparing the data, so they go hand in hand, right? Then once you identify that okay, the model is being prepared, but there is certain fine tuning which we can do to make it accurate, make it accurate to some extent, in that particular case the optimization is been happening, and this optimization is going to result in terms of your improvements and all that stuff. So when you say improvement, that means this improvement is going to be in terms of predicting that okay, what will be the next product that a particular user will be buying with the major probability, right? So how we do it, there are a number of hyperparameters that are supposed to be fine tuned. There is number of changes that you can done that can be done in the input data for training that particular model, right? So that becomes your particular fourth step, where you gain the insights from the model results by generating visualization and then fine tuning the model, and then retesting it again corresponding to your particular set of prediction statements. Then comes out as the at the end you have to summarize your results or tell as a story. So if it is a visualization related project, in that particular case storytelling is great. Whereas if it is summarizing results and so on, so it's up to you how you're going to make this particular part or make this particular step more visualized to the user, in terms of solving the in terms of giving the solution to the defined problem, right? So these are the five primary steps. Within each step there are n number of activities which you do, and every activity has its own scope, right? So this the webinar series which I've spoke about in my blog post, as well as uh, while on the registration page, is going to surround about around these steps, right? So we will be discussing about each individual type of activities that are being followed during these steps, how we spot the algorithms, which algorithm is applicable, what changes are required to be done in the applicable model, which we are trying to work around, what sort of visualization libraries which are there, what kind of visualizations visualization diagrams should be displayed, how you should be analyzing all those visualizations, and a couple of stuff. There are a number of libraries which are available, specifically Panda, sklearn, or or your Keras, NumPy. So all those libraries are supposed to be discussed during that particular webinar series. So I'm also going to discuss about the roadmap for this particular thing in the last, but still this is the primary slide, and this is the primary way around for our that particular roadmap that we are going to follow for our webinars. So now we are aware about that what are the different models, we are aware about what are the different kind of challenges which are there while defining the ML problem statements, and how we can do all the implementation steps. So this is the learning path which you should be following as a beginner, in terms of starting from scratch, or beginner level, and going to the pro or expert level, right? So here, the very first thing which you should be looking into the Python. And there is R language also, but I suggest you start with the Python. You should have some understanding of the SQL, if in case if you want to pull the data out of your specific database, right? So this is the very first step which you should be working around with, and in case if you are through with it, well and good, then you should be, on this particular stage you should learn about sklearn API, right? You can just get started with the things, but before that you should also be familiar with NumPy, Panda, and Matplotlib. Right, this is one of the most important library. I've not mentioned it here. So pandas, matplotlib, sklearn, and numpy. So these are the set of tools which you should be using or learning, which you will be using across your machine learning projects and across your career of machine learning as a machine learning engineer or researcher. So these are the primary components, or these are the primary tools which you should know about, right? And specifically if you are working if you're trying to work in a data science and relative stuff, that means you should be you should be mastering yourself with Panda and NumPy. These are the two libraries which are very 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 important. You should learn them by heart, right? And how that by heart is going to happen, you have to practice a lot. You have to practice a lot, right? So I think practicing on preparing the data is best part to use these two libraries, and then see what end results are going to happen. And matplotlib is something which is required to data visualization, because a lot of time when you visualize the data, you get to know about a lot of different kind of insights on that. Then once you're through with these, you should be start implementing the model approaches, right? sklearn, Panda, NumPy, and matplotlib at this particular stages regarding the data preparation and all that stuff. But here the sklearn is about the models, right? Generating your own models or using their inbuilt models. So if I give you a broad idea, there are a lot of different kind of neural network algorithms which are there. If you want, you can write them from scratch in Python, or if you want to remove that hassle, you can use either keras or sklearn, right? So they have implementation for corresponding algorithm. You just need to call the function and provide the required parameters, and the results will be through with you. If you wanted to implement your own work, there are estimators which are being given, which are available in the sklearn and keras, which can be used for generating your own machine learning models based on what algorithm you have generated by your research work, right? So sklearn and keras are the two core libraries which are prominently used. Okay, so till this particular place, you might be working with supervised learning, unsupervised learning. You will be working on batch learning and model based approach, right? Whereas once you go one step ahead, where you can see that we have number of different kind of uh, different kind of application, uh, big data applications are there. So Presto is one, Hive is one, Pig is one, Amazon Web Services, machine learning library of Amazon services one, Apache Spark is there, right? Cassandra is there, and so on. So anything which is going to work on the batch, on the batch and model based approach, and the supervised learning, that is actually going to harness the approach of the big data. So you have Hadoop, Hive, Presto, and the AWS related thing. Pig is also there, which you can use, which is again from Apache. It's a weird name, but yes, it is there. Then, if you are working on instance-based learning approach, right, and if you are working on incremental-based approach in that or in-stream data approach, that means you should be looking into Apache Spark, right? You should be looking into Cassandra. You should be looking into different solutions which have been provided by the Google as well as the Amazon and Microsoft Azure for processing the in-stream data and so on. So these are the various steps across your learning journey, and Now, why I've included it here, so that you should be able to appreciate that, okay, what phases are there that I should be following if I'm starting from scratch or if I'm somewhere in between, right? Every individual step has its own significance in terms of what your problem statement you're going to implement, especially these two stages, right? These two stages are very important, and they cannot be achieved until and unless you cross this hurdle, right? So you should be well aware with the numpy, you should be well aware with the pandas, you should be well aware with the matplotlib. These are the core libraries which you should start with as a beginner. When I started with, this is what approach I made. And if I tell you frankly, these three libraries actually helped me a lot in accelerating my implementation work by around 50 to 60%. I need not to search for any kind of pre-processing related manual work. So that is the primary approach you should have. Now, still, even though we are talking about machine learning, we are working on various kind of problem statements in the real life world as well. But still, even though it's almost been more than 50 years, this machine learning concept has popped up and so on. The the machine learning implementation still faces certain challenges, and one of the biggest challenge which it faces is the insufficient quality of training data, right? So why this insufficient quality of training data? Let me show you one of the thing. So this is what my Kaggle portal is, and let me take you to the data, and here are the data sets, right? So if you are not aware about the Kaggle platform, this is the platform where data scientists and machine learning enthusiasts come on and practice their skills on the machine learning part. I use Kaggle a lot in terms of getting the data sets and working around with them. So if you look at the data sets, you will find a lot of different kind of data sets over here, right? And you can actually see who has uploaded it, right? What is this data set is all about? What sort of file it contains? How many files does it contain? Is there any relevant task corresponding to it? What is the size of uh, that particular data set, and so on? So if I open this restaurant business ranking, right, and if I go to this particular set of data set explanation, you can clearly see the context they have given, the content they have given corresponding to this particular data set, right? And they have written that, okay, this is some inspiration and so on, right? But this data set has one of the challenge, that it doesn't explain about the particular set of columns. It doesn't give us a lot enough information to learn about that, what each column is about and what sort of coding they have given, right? So there is no definition which has been given for this. Whereas, let's say if we go for some, let's say, housing data. So I'm searching for some housing data, and let me open, let's say, this housing prices in Beijing. Okay, so let's go to this. So here, the difference you can see right now, whatever the CSV file or data file I'm opening, the detail which has been given is just this and the link which they have provided over here. Whereas once you go to the housing price in Beijing, and there is a CSV file which has been provided, and all the columns, what information they have, right? So ID of the transaction, URL from which it has been fetched, the longitude, latitude, community ID, drawing rooms, the number of drawing rooms which have, price, average price by square feet, and then the number of bathrooms this particular thing has. So every individual detail has been explained corresponding to each column, right? So one of the no challenge which you find in terms of data is insufficient quantity of training data is one, and non-representative data and poor quality of data. So all these three things are in fact the four things are relevant to each other. So when I say insufficient quantity of data, you will see that how many records are being mentioned. There are, I believe, how many records they have given. This has not been mentioned over here. Number of column compact. Okay, so this is the unique values it has. That is 3,18,851. Right. This is still a very small data set, right? Because if I, let's say, if I wanted to predict the price for a particular type of apartment in a particular locality of Beijing, I need to have at least 10 lakh of records so that I should be able to predict the data. If I go to the restaurant part, you can see, I think this is, there are only 50 unique values here. For this, there are no unique values they have given. Okay, so I need to just go across. So still the data is not clear over here, right? So okay, 200 for this particular file there are 250 unique values, which is a very pretty small data in terms of finding it, in terms of doing the machine learning problem solving with this particular type of data, right? Whereas if we go towards certain kind of let's say data which is like, mm, let's say these days due to COVID, the chest x-ray is very popular, right? So if we look at the chest x-ray data, we have around 2 GB of data because this is a image data right now. And how many records do we have? I think we have around 5856. Now this is the image data. So this image data is still not good enough for training a particular model correspondingly, right? So there should be some more data sets which we need to find. Maybe COVID-19. Okay, so COVID-19 data set. Let's see, 19 MB and 7 GB. Okay, so this is the COVID-19 Open Research Dataset Challenge, right? So what sort of data do we have? We have correspondingly embeddings. Just one minute. So target tables. Okay, so this is a very detailed data set, right? So we have patients, total values we get. We have measures of marginalized and disadvantaged. So still the data is very small, but there are variety of parameters or attributes we are getting, right? So more attributes we have, the more relevant informations can be, extracted from them, and to make a single data set correspondingly, right? So we have looked at around four different set of datas, right? But still you can see the relevancy of the data and the quantity of data and the representation of the data is not as good as it should be with respect to the machine learning problems, right? So that is the reason why we have literally, defined together the data from various sources, right? The relevant data, it's very very important. Without data you cannot train the machine learning model, right? So this is one of the prominent challenge. So insufficient quantity of training data is the major challenge. Non-representative training data is there. So you may you may get 100 columns, but among 100 columns maybe 95 columns are not at all relevant to you, right? The poor quality of data says, let's say you have uh, uh, 20 columns and 2 lakh records, 2 lakh records corresponding to it. But for on an average, every tuple or every record from this 2 lakh, around 12 to 15 parameters are null. What is the use of that data, right? Or let's say among these 20 columns, the columns which were of your use for the machine learning prospect, you have only 8 columns, and from among these 8 columns and 28 lakh records, from these 28 lakh records, the available data, the complete set of data is hardly 20,000, right? which is what, only 10% of the total data which is available over there, right? So this number is not going to make any difference. The actual number is this, whatever the valuable data, because that is why we said prepare your data. That is very, very important. Cleaning your data. How you clean your data? You clean your data by removing the null. You clean your data by either putting the median values in those null statements. You uh, prepare the data by removing the unwanted columns which are not supposed to be fed to the machine learning algorithms and should not be polluting your end result or end solution, right? So this is very, very important. Irrelevant features we have already spoke about. So among 20, only 8 were relevant, 12 were irrelevant. Then overfitting of the training data and underfitting of the training data. This is one of the major challenge which is related to generalization, right? So any machine learning model is supposed to be generalized across the different set of no instances which are going to be thrown at it, right? So, like the example which I've given you, corresponding to the shopping list of data, where majority of the shopping list was from the female category, but there were only few records from the male. So, in that particular case, if you train the model using that set of data, the overfitting will happen towards the female gender for that particular shopping platform. Whereas underfitting is where a particular set of, even though you train the model with that particular data, but your model prediction is not as accurate as it should be. So let's say the minimum accuracy which what we are considering is that the prediction of the next product for a particular intended customer should be having 90 in terms of training data, but when you validate it, the accuracy for that particular part reduces to 40, so that becomes a underfitting in terms of in terms of your general prospect. So these are some of the major challenges which you will find in the implementation of ML, but this is not like that you will not be able to overcome them. You can overcome, but you have to spend a lot of time. Why I discuss these challenges over here is so that you should be able to appreciate that, okay, why the activity at the step 2 is important, right? Why this thing is crucial to clean the data, so that you should be able to feed the data to the model in a very right manner, so that the end results or the efforts which you put to train that particular data should come out success as a success, right? So this is what we have in terms of the ML challenge implementations, right? Now, apart from this, there is one thing which I wanted to mention. Any of the data set which you go and look at, right, that contains the task, okay, and that task define and gives you some more clarity about that why this particular data set has been generated, right? So if you look at this particular COVID-19 open research data set challenge, you will see the tasks which are being defined. They are pretty straightforward, and they give you an idea that, okay, what is known about the transmission, incubation, and environmental stability. So this is what you are trying to find from that particular data. This is one of the tasks, and so on. And based on this data, a lot of people might have worked on this problem, right? So every problem which people every task on which the people have worked on it, there will be a certain set of a particular notebook is being initiated. So let's say somebody has worked on this visualizing the COVID-19 vaccinations, right? So here they create a kind of file for you where they have where they will analyze the data based on what sort of different kind of work they have done. So here, wherever the code is being defined, you also need to identify that which is a general description and which is basically code. So if you click on this code, you will be able to see that what sort of imports are being done corresponding to that particular model implementation. So another set of code is from where the data has been read. So data has been read from the country vaccinations, right? Then they give you the description about it. Then they read about, now this data is being fetched by using if you look at the PD is basically what pandas allies, right? So you have a data frame of panda, and that data frame has been displayed over here. So head gives you first five records from that particular fast data, and then the another code set, you can see how the columns have been prepared corresponding to the country and so on, right? So this is what you get in terms of your implementation. So just to have an idea that how people are working on that particular data set, you can actually go to their notebooks, public notebooks, and go through their code, that what exactly they are trying to work on. And this is like total vaccination. They have given they have generated a particular plot based on that, how many countries have vaccinated how many people, right? The total vaccinations which have been given, and fully vaccinated, they are also being provided over here. The countries which are using the vaccinations, that is also provided over here. So this is some kind of uh, you know uh, a sample solution which you have. And if you think about the problem, and if you see the solution, and if you find any improvement into this, that becomes your novel work, right? So this is the approach, I think, which you people as a beginner can start with, and can start learning from the others work. You can also get involved into the discussion, because if you look at each individual notebook, there is a discussion at the end of that particular notebook, right? So this discussion is basically specific to that particular notebook which this person has created. Whereas if you wanted to have a general discussion on this particular data set, this is the discussion section where you can go and check out on the things, right? And then comes the activities, that what activities have been followed on this particular data set. So they all are in here, and there is a metadata which is associated with this particular set of challenge that has been generated, right? So this Kaggle platform is one of the best place. I've also used it for fetching out a lot of different kind of data, and I found a very good data set with respect to my problem statement on which I have been working on. So the point comes is the challenges are there, but you need to find out a way to overcome it. And Kaggle is the best platform to start working with, and start getting the idea that how people are working around the set of problem statements that are there, right? So that is what I have correspondingly for this particular webinar. I think I have overshooted it by 40 minutes. But anyways, so I quickly conclude the session. The roadmap for the upcoming webinars which are there, I'll be talking about the various concepts of working with the data, right? That's the very first thing. We'll be talking about cleaning the data. What are the different ways, what are the different approaches that we have? We are also going to talk about that, how the data can be populated if there are plenty of null rows corresponding to certain required columns, and so on, and how we can combine number of data sets together to build up one single data, and how the features can be extracted out of them, and so on. Once the working with data is over, then hands-on with different categories of machine learning approaches will be done. So supervised learning, unsupervised learning, we'll take some sample algorithms and we try to implement them in our system, in our webinar, right? And this will be totally hands-on approach, and will be followed by some assignments as well. And then comes is the testing and validating of the machine learning solution. This is very important, where we are going to do some improvement related things. We are going to learn about the different procedures, that how we are going to find out the optimized values for the hyperparameters which are there in these machine learning algorithms, right? So this is the basic approach. So three stages. So there might be uh, four webinars, or there might be six webinars, depending upon what is the pace we are going to have while explaining all those concepts, right? So 4 to 6 webinars I am expecting in this particular series. And this is the webinar schedule which I'm going to follow. So there will be a Zoom session per week which will be 1 to 2 hours long, right? Where we'll discuss about the different kind of concepts, and we are also going to talk about various set of uh, you know uh, uh, algorithms and approaches that can be done, and this particular session will be followed by an assignment. Now this assignment is a self-paced assignment. Uh, you can follow it on your pace. There will be no specific submissions required for this particular assignment. This is purely for practice purpose, but definitely there will be a Q&A corresponding to your doubts while solving those assignments. So that is what I have planned for. So that is again done in during that particular session, in that particular week, whatever the uh, schedule will be. The day of the session will be Saturday or Sunday, whatever the suitable day we have, as per the common understanding. And the timing will be 10 a.m. This is the tentative timing, so this can be 10 or 11 depending upon what my availability is in terms of the delivery prospect, right? So once the time is decided, once the number of registrations are there, and once the once we have general you know what do you say, input from everyone, then the timing and the session day will be decided correspondingly, right? So we will have one small session where we decide on this. So how you can approach and how you can get into this particular series of machine learning sessions, you can go to this particular link, or you can scan this QR code, right? This QR code will get you a form to fill, and both this link and the QR code are same, right? So you can go to anupinder.com/ml register. You can register on that particular form, and once your submission is with me, your entry is with me, I'll be sending you the email for the further steps of working. So if you want, you can register right now. If you want to register it later, you can just note down the link. This is anupinder.com/ml register, right? So right now I'm just switching on the chat as well. uh, yeah, so I'm switching on the I've just switched on the chat, and I've just switched on the setting for unmuting yourself. Now you have both the options with you. So if you have any kind of questions or any kind of queries, you are no welcome to ask, either by turning on your mic, or by writing in your chat window, right? And these are some of the handles where you can reach me out: at the rate Anupinder on Twitter, and me at the rate anupinder.com is my email. You might have received an email from online courses at the superwits.com. That is another email which you can approach to as well, right? So that's what we have for this particular session. You have any queries, I'm open for the queries. I'll be here for another 5-10 minutes till the time you have queries for me. And in the meantime, if you want to get the registration done, you can go to this particular link, or you can scan the QR code, and then you can work it around. Okay, so let me take the question. Aftab has asked, I'm working on incremental learning based ID in uh, okay, so I'm working on incremental learning based ID in fog environment. How will it help me intrusion detection? Okay, so for this, Aftab, I think the best approach which you can use is the reinforcement learning. Maybe you can start with some assumption based model, and then you can approach that particular problem by using ap- that penalty and reward structure, right? So there are a number of reinforcement learning algorithms which can be there for you, that you can work around. But initial rules you have to define correspondingly. Okay, so somebody has asked for sharing the link. So it is anupinder.com slash ml register. Right, so link I've sent on the chat. Okay, so after regarding the reinforcement learning, generally neural networks are the one which can be used for this. and there are other algorithms as well. So I need to find a list for you. So maybe you can join the webinar series, and we can have a discussion corresponding to that as well, right? So let me also go on. Uh, okay. So any more questions we have? So does this make sense to you guys? Like whatever we have discussed during our last. Okay, the link is not working. Well registered. Let me check on my end. The.com/ml register. It is working. This actually looks like this, or you can use this as well. Let me do this for you. So here is the another link which you can follow. This is the direct link. All right. So I was asking that does it make sense to you guys that whatever we have discussed? I hope this has made some clarity of thoughts in your mind as a beginner. So anyone wants to share anything? I'm here. So I'm going to stop sharing my screen, right, so that I can get on to the mode of yeah. So I can see all the participants now. View gallery view. Yeah, great. All right. So I think I've missed to put on my headphones. Great, Claudine. So that means you are able to register. Great. So anyone wants to ask question, or otherwise we can call off the session for today. I think in India it's almost like 10:30. Okay, so looks like all the queries are over, and thank you very much for joining in to this particular session, and thank you very much, so very much for listening to me very patiently. This was like kind of my first webinar on machine learnings, and such a deep discussion with such a deep discussion, and hope this might have made some difference in your learning. The recording will be available, yes, definitely, and the recording I'll be sending you the recording after this session, maybe in 2 or 3 days, once I process the recording. Okay. Even though I have made this particular webinar online, yeah, this was live on my YouTube channel, so you can search for Superwits Academy. The name is Superwits Academy, and you can search for uh, get started get started with machine learning, right? So you can have a video over there. Okay. So this is what I have for today's session. I hope to see you in the no, series of lectures. and I hope you will have a great learning during those lectures and while solving the assignments. And we as a group have a great uh, learning with all the implementation part of the machine learning, right? So thank you very much. Goodbye. Good night.